In this episode, we're going to take the calm, plain English understanding of AI from the last lesson and use it to answer the question that matters most in risk work. Where does AI go wrong in real life, and why does it so often surprise people? Beginners sometimes hear about AI failures as if they are rare accidents that only happen to careless organizations. But the truth is more uncomfortable and more useful. AI can go wrong in predictable ways, even when smart people have good intentions. The good news is that once you learn the common failure patterns, you stop treating AI as magic and you start treating it as a system with known weak spots. That shift is powerful because it lets you ask better questions, spot risky use cases early, and avoid the two extremes of blind trust and total fear. We will focus on four major categories that show up again and again: errors, bias, drift, and misuse. By the end, you should be able to describe each one in plain terms, explain why it happens, and recognize what it looks like at work before it becomes a headline. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Let's start with errors, because that is the simplest and most universal way AI goes wrong. An error is when the system's output does not match reality or does not match the goal the organization cares about. This might look like a wrong classification, like marking a legitimate transaction as fraud, or it might look like a wrong recommendation, like suggesting the wrong product to a customer. In a generative system, it can look like a confident statement that is simply false, or a summary that leaves out a critical detail. Errors happen because the model learned patterns from past data, and those patterns are never a perfect map of the real world. The real world is full of messy edge cases, exceptions, rare events, and new situations that training examples did not capture. When you hear someone say an AI system is 95% accurate, remember that the remaining 5% can be concentrated in exactly the situations that matter most, like safety events, vulnerable customers, or unusual but high-impact cases. A key beginner concept is that errors are not always evenly distributed, and that matters for risk. An AI system can perform well on average while still failing badly in a narrow slice of cases. Imagine a medical triage system that is mostly correct, but it struggles specifically with rare symptoms, or it struggles with notes written in certain styles. Imagine a customer support classifier that works fine for common issues but misroutes tickets that involve billing disputes, which are emotionally sensitive and legally risky. This is why risk management often cares about worst-case impact, not just average performance. It also explains why organizations can feel blindsided, because their early tests may not include the rare cases that later cause harm. When you build your risk thinking, always ask not only how often the system is wrong, but also who is harmed when it is wrong and whether the harm is tolerable. Now let's talk about bias, because that word gets used in many ways and beginners deserve a clear, usable meaning. Bias, in the risk sense, is when the system's outputs systematically disadvantage certain people or groups, or when the system's behavior reflects unfair patterns in the data or the process. This can happen even if the model never sees a sensitive label like race or gender, because other signals can act as indirect proxies. For example, location, education history, or even writing style can correlate with protected characteristics, and the model can learn patterns that reproduce historical inequality. Bias can also appear because the data is missing representation, like having fewer examples from certain communities, which causes the model to be less accurate for them. Another source is labeling bias, where the past decisions used as truth were influenced by human prejudice or inconsistent standards. The important point is that bias is not just a moral issue. It is a risk issue because it can create legal exposure, reputation damage, and real harm to people's lives. Bias can show up in subtle ways that are easy to miss if you only look at overall performance metrics. A system might have the same overall accuracy for different groups, but still produce different types of errors, like more false positives for one group and more false negatives for another. A hiring-related system might filter out candidates who would succeed because it learned to favor signals that reflect past hiring patterns rather than true job ability. A credit-related system might assign higher risk scores to communities because historical data reflects unequal economic conditions, and the model treats those conditions as if they are individual choices. In each case, the harm is not just that the model is wrong, but that the wrongness has an unfair pattern. For a beginner, the practical takeaway is that fairness requires looking deeper than averages, and responsible AI use requires a willingness to test and monitor for these differences over time. Drift is another common way AI goes wrong, and it is especially important because it can happen after a system appears to be working. Drift is when the world changes in a way that makes the model's learned patterns less reliable. You can think of drift like learning to drive in a quiet small town and then being asked to drive in a busy city without additional practice. The same rules apply, but the environment is different enough that your old habits can get you into trouble. In an organization, drift can happen when customer behavior shifts, when a new product launches, when a policy changes, when fraud tactics evolve, or when the language people use changes. Even something as simple as a new form field or a new workflow can change what the model sees as input, which changes how it behaves. The dangerous part is that drift is usually silent at first because the system still produces outputs and people keep trusting it. Without monitoring, drift can turn a once useful system into a quiet risk generator. There are a few flavors of drift that matter for intuition, even if you do not memorize names. Sometimes the input data changes, meaning the kinds of cases the model sees are different from what it saw during training. Sometimes the relationship between input and output changes, meaning the same signals no longer mean the same thing, like a purchasing pattern that used to indicate loyalty now indicating stress because of economic changes. Sometimes the labels change, meaning the organization's definition of what is correct shifts, like redefining what counts as high-risk behavior. In all these cases, the model is not necessarily broken, it is simply out of date. That is why ongoing monitoring and periodic reevaluation are part of responsible AI governance. If an organization treats AI like traditional software that stays stable until someone edits it, it will miss drift and end up confused when outcomes change. Misuse is the fourth category, and it is often the most human one, because it is about how people apply AI rather than how AI behaves internally. Misuse happens when a system is used in a way it was not designed for, or when people rely on it beyond its proven limits. This can be intentional, like using a tool for surveillance or manipulation, or it can be accidental, like a team using a summarizer to make legal decisions because it saves time. Misuse also includes situations where employees use public AI tools with sensitive information, not because they are malicious, but because they are trying to be efficient and do not understand the risk. Another kind of misuse is automation bias, where humans assume the system is right because it is automated and appears confident. Misuse can turn a low-risk tool into a high-risk system simply by placing it into a high-impact decision process. For risk management, misuse is a governance and training challenge as much as a technical one. These four categories overlap, and that overlap is where real-world risk becomes complex. A system might have ordinary errors, but those errors might disproportionately affect a certain group, creating bias. Drift can increase error rates over time, and if the drift affects some populations more than others, it can amplify unfairness. Misuse can create harm even if the model's accuracy is decent, because the problem is the decision context, not the raw output quality. This is why AI risk programs emphasize context, impact classification, documentation, and oversight rather than relying only on technical performance measures. When you evaluate an AI system, you should ask what the system is being used for, what the consequences are, and who will be affected if it is wrong. That mindset helps you avoid narrow thinking like focusing only on an accuracy number. Risk is about outcomes in the real world. Beginners often ask how to recognize these problems early, before harm occurs, and the answer starts with patterns in how the organization talks about the AI. If people describe the system as always correct, that is a warning sign, because no model is always correct. If the organization cannot clearly state the system's purpose, limitations, and expected performance, that is another sign, because unclear expectations make misuse likely. If the system is used in high-impact contexts without clear human oversight, escalation paths, and accountability, risk is usually accumulating. If nobody can explain what data the model learned from or how it was evaluated for fairness and reliability, the organization may not be able to defend decisions later. If performance is not monitored after deployment, drift can quietly break trust. These are not technical red flags. They are operational and governance red flags that a risk-minded person can spot without writing a line of code. Another way to recognize AI going wrong is to watch for mismatch between confidence and evidence. AI outputs often look polished and decisive, but the real question is whether the organization has evidence that those outputs are reliable in the specific setting where they are used. Evidence can include evaluation results, documented limitations, monitoring reports, and clear rules about when humans must review or override. When evidence is weak, reliance should be limited, especially in high-impact decisions. Organizations sometimes treat AI as a shortcut for uncertainty, using it to replace careful judgment rather than support it. That is risky because the AI is also uncertain, just in a different way. The safest approach is to use AI as one input in a controlled process, where humans are trained to question it and systems exist to catch failures. When you see AI being used as an authority rather than a tool, you should expect error, bias, drift, and misuse to become more likely. Because you are working toward an exam mindset, it helps to practice how these concepts show up in exam-style questions. If a question describes a system producing wrong outputs in rare but severe cases, you should think about error and high-impact risk, and you should expect the best response to involve evidence, testing in edge cases, and oversight. If a question describes unequal outcomes for groups or a concern about discrimination, you should think about bias and fairness evaluation, and you should expect controls around data, testing, and monitoring. If a question describes performance degrading after a business change, you should think about drift and the need for ongoing monitoring and periodic reassessment. If a question describes employees using a tool for unintended purposes or trusting it too much, you should think about misuse and governance, including policy boundaries and decision rights. This kind of mapping turns abstract concepts into practical recognition, which is what the exam rewards. You are not memorizing words. You are learning to identify patterns. We should also address a subtle but important point. AI going wrong does not always look like a dramatic failure, and that is why it can persist. Sometimes harm is slow and spread out, like slightly worse service for certain customers, small inaccuracies in summaries that gradually create bad decisions, or mild unfairness in rankings that compounds over time. Because the harm is not a single explosion, it can be ignored, especially if the AI is saving time or money in the short term. Risk management pushes against that temptation by requiring documentation, accountability, and monitoring so small harms do not become normalized. It also encourages organizations to think about the people affected, not just the efficiency gained. A system can be profitable and still be harmful, and that is exactly why AI risk is not only a technical conversation. It is a governance conversation about what outcomes the organization is willing to accept. To close, recognize that errors, bias, drift, and misuse are not rare surprises. They are predictable categories of failure that show up repeatedly when AI meets real-world complexity. Errors remind us that AI is pattern-based and will be wrong sometimes, especially in edge cases. Bias reminds us that data reflects history and society, and without careful evaluation, AI can reproduce unfairness and create legal and reputational harm. Drift reminds us that the world changes and models can become stale, requiring monitoring and reassessment rather than blind trust. Misuse reminds us that humans and processes can turn a tool into a liability by applying it in the wrong context or trusting it beyond evidence. If you can explain these four concepts clearly, you have a strong foundation for later topics like business harm, governance, assessment, and monitoring programs. Most importantly, you will have a practical lens you can apply to any AI use case you encounter, which is exactly what AAIR risk thinking is meant to build.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.